Hello students, in the last lecture we have discussed Thevenin's theorem. Okay, and the statement of Thevenin's theorem is any complex network can be converted into a simple network consisting a voltage source and a series resistance. Voltage source called VTH means Thevenin's voltage, and resistance called as Thevenin's resistance. In this lecture we will discuss some example of Thevenin's theorem. First example is find the current through 2 ohm resistance called load resistance by using Thevenin's theorem. The circuit diagram is as shown in figure. Here V1 is 10 volt, R1 is 4 ohm, R2 is 6 ohm, and load resistor RL is equal to 2 ohm. The load resistor is connected between terminal A and B. Okay, then first step, we will calculate the load current value in 4 steps. Then first step is calculation of VTH means Thevenin's voltage. Okay, calculation of Thevenin's voltage. The Thevenin's voltage is open circuit voltage between terminal A and B. It is a open terminal voltage between terminal A and B, and it is given by, or we simplify this circuit 1. This circuit become, this is V1 10 volt. Okay, this is R1 4 ohm, this is R2 6 ohm, and this terminal is A and B, and the voltage between these two terminals called as VTH. This voltage is VTH, the terminal voltage VTH. Okay, by using voltage division rule we will calculate the voltage between terminal A and B. The voltage between terminal A and B means the voltage across resistor. This is voltage across resistor R2, means the voltage measured at A and B is the voltage across resistor R2. Okay, this voltage measured between A and B is similar to the voltage between, this is voltage between R2. By using voltage division rule we will calculate the VTH, and the formula of voltage division is voltage measured across R2, means voltage at R2 is given by R2 divided by total voltage, is total resistance in the circuit is R1 plus R2. It is closed circuit, then its resistance is R1 plus R2 multiply by applying voltage V1. Okay, then by substituting value of R2, R1, R2 and V1, R2 is 6 ohm divided by R1 4 ohm plus R2 6 ohm multiply by V1 voltage 10. Okay, it becomes 6 divided by 10 multiplied by 10, then cancelling this and this, it becomes 6 volt. Okay, means VTH is equal to 6 volt. Okay, it is VTH is open circuit voltage. It is a open circuit voltage. The next step is calculation of RTH. Okay, in this circuit we have calculate the value of VTH. Okay, before calculation of VTH we remove load resistance RL. Between the terminal A and B, the value of load resistance is 2 ohm. Okay, then the measured voltage at the terminal A and B, it is VTH, and this voltage is the across resistor R2. Therefore, by using voltage division rule, VTH is equal to R2 divided by R1 plus R2 multiplied by V1. By substituting value of R1, R2 and V1, then VTH is equal to 6 divided by 4 plus 6 multiplied by 10, and the final value calculated VTH is equal to 6 volt. Okay, then next step is step number 2, calculation of RL. Step number 2, calculation of RTH. Calculation of RTH. What is RTH? RTH, Thevenin's resistance. And Thevenin's resistance is calculated by short circuiting the ideal voltage source and open circuit resistance for ideal current source. Okay, शॉर्ट सर्किट जर आयडियल व्होल्टेज सोर्स असेल तर आणि ओपन सर्किट करायचं जर आयडियल करंट सोर्स असेल तर. ओके, हियर इन दिस सर्किट here it is a ideal voltage source, means it has no internal resistance. Okay, then this circuit becomes like this. This is the voltage source and this is short circuit, means here is. Then second part is resistance R1 and the value of resistor R1 is 4 ohm. Okay, then here short circuit. Then resistor R2 6 ohm, and then terminal A and B. and the resistance between these two terminals called as RTH. What is RTH? RTH means Thevenin's resistance. Okay, RTH means Thevenin's resistance. Okay, in this figure, resistor R1 and R2 are parallel. Parallel means these two terminals of resistor R1, okay, these two terminals of resistor R1 are connected to similar to terminal R2. Okay, means these connections are parallel connection. Means I simplify this diagram into okay, this is R2 and this is R1, and this is terminal A, B and RTH. Okay, then the value of R1 is 4 ohm and the value of R2 6 ohm. For parallel resistance calculation, RTH is equal to R1 parallel R2. Okay, and the formula for parallel resistance is R1 R2 divided by R1 plus R2. Okay, then here the value of R1 is 4 ohm, R2 is 6 ohm divided by 4 plus 6 means it is 24 divided by 10, and its value is 2.4, means final calculated value of RTH is 2.4 ohm. Final calculated value of RTH is 2.4 ohm. Okay, then Thevenin's equivalent. Step number 3. Thevenin's equivalent circuit. Thevenin's equivalent circuit. Okay, Thevenin's equivalent circuit consists one voltage source. Thevenin's equivalent circuit consists one voltage source called VTH and one series resistance called as RTH. Okay, and this is terminal A and B and the load resistance RL. The value of VTH by calculation is equal to 6 volt. Value of RTH by calculation is 2.4 ohm, and the value of load resistance is RL is equal to 2 ohm. RL is equal to 2 ohm. Okay, this is a Thevenin's equivalent. Okay, we will see again these steps. The step first is calculation of example is example find current through 2 ohm resistance by using Thevenin's theorem. Okay, the circuit diagram is V1 10 volt, R1 4 ohm, R2 6 ohm and RL is equal to 2 ohm. First step is calculation of VTH means Thevenin's voltage. It is a open circuit voltage. It is calculated by removing a load resistance RL from terminal A and B. Okay, by removing load resistor RL, the voltage measured at terminal A and B. This voltage is similar to the voltage across resistor R2. By using voltage division rule, we will calculate the VTH, and the formula of voltage division rule is R2 divided by R1 plus R2 multiplied by V1. Okay, by substituting the value of R2, R1, R2 and V1, the final resulted value is VTH is equal to 6 volt. Okay, then step number 2, calculation of RTH, means Thevenin's resistance. Okay, Thevenin's resistance, it is short circuit resistance for ideal voltage source, and it is open circuit resistance for ideal current source. If here is ideal voltage source, then we will short circuit the terminal of voltage source. Then the resistors R1 and R2 becomes parallel, so the final value of RTH is equal to R1 parallel to R2, and the equivalent resistor is R1 R2 divided by R1 plus R2. By substituting value of R1 R2, it becomes 4 multiplied by 6 divided by 4 plus 6, it is 24 divided by 10, means 2.4 ohm. Then we will draw the Thevenin's equivalent circuit, and it is VTH is equal to 6 volt, RTH is equal to 2.4, means by Thevenin's theorem, any complex network can be converted. Simple network consists a voltage source VTH and resistor RTH, and resistor connected in series, and the terminal A and B, and the RL is equal to 2 ohm. Okay, then last step is step number 4, the calculation of load current IL. Step number 4, calculation of load current IL. In this circuit, the current flowing through resistor RTH and load resistor RL is IL. Okay, and by using Ohm's law, V is equal to IR. The formula of Ohm's law is V is equal to IR. Here I is IL, here I is IL, V is VTH, and R is two resistors are in series, therefore RTH plus RL. What is the value of R? RTH plus RL. Okay, therefore IL is equal to VTH divided by RTH plus RL. Okay, VTH is here 6 volt. Here the value of VTH is 6 volt. Then RTH 2.4 ohm plus RL is 2 ohm. Then 6 divided by 4.4 and it is around 1 minute. Calculation 6 divided by 4.4 and it is around 1.36 ampere. 1.36 ampere. In this way, we will calculate the load current IL, load resistance RL, and its value is here 2 ohm. Okay. Then we will see again step number 4, calculation of load current IL. By using Ohm's law, V is equal to IR. Here V is VTH. Then I is IL, and R total resistance RTH plus RL, and IL is equal to VTH divided by RTH plus RL. Then by substituting values, VTH 6 volt, RTH 2.4 ohm plus 2, and the final calculated value of IL is equal to 1.36 ampere. Okay, we will stop here and next example see in next lecture.